Good evening, guys. Welcome to the session. People are still joining. We'll wait for another few minutes. Let everyone join the session, then we'll start. Yeah, Kanishka Sharma. Understood. But you have to complete the all things. Okay. So that's the criteria of getting the certificates. Okay.
Good evening, everyone. So it's been like a very long weekend, right? Yeah. Yeah. Okay, fine. So in our last session, we are done with the evaluation metrics, right? Evaluation metrics for what? For both regression and also classification, we are done, right? Both evaluation metrics we have discussed in clear. Correct. So in regression, we'll be having RMSE, MSE, MAE, R square, and in classification, we have true false confusion matrix table. Based on the confusion matrix table, we'll have this specificity, sensitivity, precision, accuracy, F1 score. Correct, remember? So in our last session, just a moment. So in our last session, we were about to discuss this decision tree algorithm, right? Remember? So we have just only discussed an overview format, right? We have discussed in the format of an overview what exactly the decision tree algorithm is, correct. So now we'll be discussing what exactly an entropy, Gini index, all those decision tree metric factors, okay. How exactly the root node is decided. All those factors we'll be discussing. Fine. Today we'll discuss all those things, decision tree and random forest, both. And if still time permits, we'll go for KNN or yeah, KNN or K-means algorithm we'll discuss. And in between, if anyone is having any doubts related to the session, then please let me know in the Q&A, okay? So I hope I can start the session, and I see very less people today. I don't know why. Only 53% present today. Okay, it's fine. We'll just start the session. So what do you guys remember about this decision tree? In the meantime, I'll just share the screen. Please let me know what you remember about the decision tree. So our last session was on Wednesday, correct? Let me just switch to decision tree. Okay. And let me just share my screen. Okay, here we are about to discuss about the decision tree, correct? And we all know decision tree is a supervised machine learning algorithm, which will be splitting the features or the columns, correct? It will be splitting. How it will be splitting? It will be splitting recursively, correct? Remember, it will be splitting recursively, and it will be doing the classification. In this, we'll be having how many nodes? 3 nodes mainly, correct? A root node, decision node, and leaf node. What does a root node do? A root node is the topmost node, correct? The topmost very first node in the tree is the root node, which will represent our entire data, correct? And how the splitting happens? How the splitting happens? It will divide the data into subsets, correct? It will divide the data into subsets based on the each feature. Each feature in the sense each column which has been considered, or else each feature value which has been considered based on that, the splitting will be happening. Correct. Then what happens? Then comes the decision node. Okay. Decision node is what? A node which is representing a feature again. See, splitting means on one single feature it will be divided, and after dividing whatever the nodes which we are having, each node is considered as a decision node, and after recursively going through that splitting process we'll get a last node. Last node is a leaf node. Okay, what does the leaf node do? It will represent the predicted class label or the target value. Okay, fine. So just gone through this, and we have gone through this example also. See, root node, the splitting is happening. These are all the decision nodes. In between nodes are the decision nodes. This high and normal are the leaf node. Okay. Outlook is the main root node, and the splitting process is happening. The overcast, sunny, humid, rain, wind, all these features or attributes are considered as a decision node, and high, normal, weak, strong are considered as a leaf node. Okay. We'll just move forward. Okay, we have considered this output also. What could be the output for the regression trace? Numerical values, correct? Regression means, and classification, categorical. We were already done with this, correct? Target variable will be continuous, discrete, objective. Minimize the mean square error. See, mean square error value. Remember? And maximize the Gini index, and we need to discuss about this Gini impurity and entropy. Correct. We need to discuss about all these factors. Then we are done with all these particular specific, right? The output will be in regression classification, how the target variable will be, what is the objective, visualization, example. All these things will be done once we go with Gini index and entropy. Okay. Fine. So these are some advantages and disadvantages. We'll go through them. So this is just a representation of how the splitting is happening. First, initially a diameter size is considered. Based on the size, small and large, they were divided. And again, in the large, we are having this color category, blue and green. Okay. This is how the splitting is happening in example representation. And yeah, see this. I'm sorry. So in a mathematical way, how will we choosing the best feature to split? Best feature for splitting purpose. What is this best feature represent? Best feature will represent the root node, correct? Best feature will represent the root node. See over here. Here we are considering all the no values. Play no, where the play is no. We are considering all those values. We are having sunny, high, weak and strong for no, and rain, normal, strong, no, sunny. See the play values. See, play will be the target because here the play will be the target because here we can see it is in binary format also, and if we just mention like play yes or no, we won't be understanding. We won't be understanding like what exactly it is referring to. So this particular column is a dependent column on all these columns, correct? Outlook, humid, wind. On all these three columns, the play column is dependent column, correct? So based on these factors, now we'll see how many values are we having for no. Let's see, 1, 2, 3, 4, 5. 5 values for no, and the remaining 7 values, 7. Remaining values we are having for S, correct? Not 7. So how we are calculating the entropy? Just see, entropy. What exactly is entropy and what is this calculation? Okay. Anyone heard of entropy? See, entropy is nothing but it will measure the randomness of the node, okay? Randomness of the node. Entropy will help us to measure the randomness of that particular node, okay? Anyone heard of entropy? Anyone heard of entropy in employee performance? Okay. Yeah, randomness, correct. Vinay, I will address that query, okay? Okay, fine. Okay, so this is the formula you can see pi log 2 pi. So what exactly this formula means and how the calculations are happening. I will just say with one example or else you can see over here. Entropy is, remember that entropy is nothing but it will measure the randomness, okay? It will measure the randomness of that particular node. Here see number of the samples. How many samples are we having over here? Total 14 samples we are having. So we'll consider those 14 samples where S, they can play tennis. How many number of S we are having? 9. Correct. So 9S and 5 no. Correct. 9S and 5 no. So how we are calculating the entropy? Just see. So we are considering the S samples by total number of samples to log 2 by again the same. Again we'll consider for S samples and no samples. Okay. So we'll get a certain value over here for both S and no samples. And we'll be getting a value around 1.56. Understood this calculation? 9 by 14 is around 0.94. Log 2 of 9 by 14 is negative of 0.76. Again 5 by 14 0.36. Log 2 of 5 by 14 is minus 2.32. So 994 into 76 will give a value of 0.72 and 36 into 2.32 will give a value of 0.84. So both are negative. So we need to do addition over here. After adding, we are getting a value of 1.56. Correct. 1.56. Understood this entropy calculation? See, initially what we did, how did we calculate the randomness? How did we calculate the randomness? And why do we calculate the randomness? The lower value will indicate the better split, okay? The lower values will indicate the better split. And to understand those lower values, first we'll consider our target column and we'll do the value counts, okay? We'll do the value counts and based on the value counts, we'll apply this formula. The formula is pi log 2 of pi. What is pi over here? First, we'll consider the two different values for S and for no, because we are having two different values here in the target column, S and no. So for S, we are having 9 samples, for no, we are having 5. So total values of 14. So 9 by 14 log 2 by 9 by 14. So in a similar way, 5 by 14 log 2 of 5 by 14. So that is how we are calculating the whole entropy. But if you see over here, we can get like C is the number of the classes. So how many number of classes we are having? 2. From I starting from 1 to at least we'll have one value, right? Just go through this formula once. Just go through this formula. Sigma I to 1 to power of C, Pi log 2 of Pi. So I could be 1, at least the target value could be 1 ranging from 1 to C. And how C will consider? C will be considering based on the target column values. Okay. So here our target column is play. How many different values we are having? S and no. Correct. So C will be 2. I from 1 to 2. Okay. 1 to 2 we will consider. Fine. What is Pi here? Pi is the probability of the class I. Okay. The probability of the class I. So how we are calculating it? The probability, total number of samples, and we are considering the number of S samples and also no samples. Correct. The whole data set also. See, whole data set S is 14, S is 14, 9 is Pi, right? I mean I, if you see. So that way we are calculating this probability and the log 2 of this pi I again. Okay. I hope entropy is clear, right? Entropy calculation. Entropy calculation, any doubts, anyone? Clear, doubts? Yeah, I see someone is having a query. Yeah, if anyone is having any doubts related to this entropy, you may ask, okay? Okay, so now we have seen what exactly entropy and why we are calculating entropy, right? But why exactly entropy is required over here? Why do we need to do the calculation in the first case? See, we need to calculate entropy because, yeah, I'm explaining it. Okay, we need to calculate entropy because we need to decide which feature should be the root node. Okay, which feature should be the root node? We need to decide that. Yes, so that is the reason we are calculating the entropy. And again, if you refer to the formula over here, see, sigma I to 1 to power c pi log 2 pi. What is this pi? Pi is the probability. Probability of what? The class I in the data set. So in the data set test means how many values we are having in the data set? 14 values. Class I. So in that whole data set, we are having a target column, correct? Target column was play. And how many classes we are having in the target column? 2 classes. Yes or no? Correct. Yes or no? Correct. So now we need to calculate the probability for yes and probability for no by considering the total values in the data set. Correct. And if you see the calculation over here, what is the C? C is nothing but 2. How many classes they are having? 2 classes. Understanding? Understood now? Or do you want me to explain once again? And also Akashdeep, Sharma, Vinay, Shashank, Kanishka. Understood, right? I mean, randomly I'm calling few names, okay? Okay, fine, got it. So now entropy calculation is clear. And why exactly entropy is calculated? Entropy is calculated to decide which feature to choose first, or else which attribute of which feature should be the root node, okay? Root node. See, in the last session, one of the person was, one of our friend was having a doubt like, wow, how do we decide which column or else which feature or else which attribute will be the root node? So this is based on this entropy only, we'll be calculating the root node, okay? And we'll just proceed forward, okay? So we just got this entropy score as 1.56. So then what are we doing over here? After entropy, we'll calculate the information gain, okay? Information gain. And how information gain is calculated? Based on the entropy only, the information gain is calculated. Okay? Based on this entropy only, the information gain is calculated. See this calculation clearly now. So based on this only, it will be decided, okay? Based on this calculation only, the things will be decided. So what's the formula over here? For the information gain, and we are considering what we are considering S and A. So I will say what S and A is. We'll just proceed with the formula. Then we are considering the entropy for the whole data set, and then we are considering this sigma of V to A, where S of V by S. I mean the whole data set where we are applying that mod also. And again, we are multiplying the whole thing with entropy over here. See. So this is the formula, but initially to calculate the information gain, we need to know entropy. So that is the reason first we need to calculate the entropy, okay? Entropy. And how we are calculating this information gain? If you see over here, where A is a set of values for that particular feature. In each feature, what are the set of values present? Okay, that will be A. And SV, what is this SV? SV is the subset of samples for which feature A has values B. S is nothing but the, SV is nothing but the subset of samples, okay? Subset of samples for which feature is. So let's consider feature is sunny, or else feature is just like a outlook, okay? Just consider feature is outlook. So in that first, so how many values we are having, how many classes we are having in the outlook? Sunny, overcast, rainy. So 3 classes, correct? So now each class samples will consider. So each class will be considered as a subset of samples. So that will be SB, okay? That will be SB. I hope everyone understood until here. If still having a confusion in this S and A, we'll just proceed forward. You will understand clearly, okay? So then, based upon this S value we got from entropy, okay? S value we got from entropy. All we need to do is now, what we need to do now? We need to calculate this SV and S. So now just see. Now we are calculating the information gain for the outlook feature, and we are splitting the data set based on the outlook. First, initially, we'll consider each and every column, okay? Each and every column. First one is outlook, or else any other columns we'll consider. So let's consider the first column is outlook. In the outlook, how many values we are having? Sunny, rainy, and overcast. So these are all the 3 different values, correct? These are all the 3 different values present in the outlook. So sunny is having 5 samples. Overcast is having 4 samples. Rainy is having 5 samples, correct? So 5, 5 and 4, or else 5, 4 and 5, correct? So in that sunny 5 samples also, 2 are for no, 3 are for yes, okay? And even for overcast, how it is? Overcast it is 0 no and completely 4 for yes, correct? So similarly, if you check for rainy, 3 no, 4s, correct? 3 no, 4s, fine. So these are all the one single feature. In one single feature, we are having subsets. Subsets which are, what are the subsets? Sunny, rainy, and overcast. In that subsets, we are having sample values. 2 no, 3s, 3 no, 4s, 0 no, 4s. Correct. So in that also, what we will be doing is we'll consider each and every class, okay, each and every class, and we'll calculate the output. So first, initially, what are we considering? We are considering for sunny. Okay, we are considering for sunny. So sunny, how many samples we are having? 5 samples. Total how many? Total how many values we are having? 5 values. In that, how many values which are going for yes and which are going for no? 2 for no and 3 for yes. Correct. 2 for no and 3 for yes. And again, if you see over here, we are doing the log. And what is this? We are calculating the entropy value. Entropy value, okay? We are calculating the entropy value for sunny. Just for sunny itself, we are calculating. In the previous slide, we have seen how to calculate the entropy. Here, we have actually seen how we are implementing the entropy in the information gain. So we are considering here sunny, and in the sunny, we are having 2 no and 3 yes. So 2 by 3 and log of 2 by 3 again, and again here 3 by 2, log of 3 by 2 again. Then we are getting a value of 0.97. We are getting a value of 0.97 for that. Then we are implementing that entropy value in this whole formula, okay? In this complete formula, in this information gain calculation formula, we are implementing that, okay? Here entropy is 1.56 minus this whole values, okay? This whole. And how we are getting this entropy again of S of V? S of V is nothing but what? S of V is nothing but subset of samples. Subset of samples. So what is the subset in outlook here? Sunny, rainy, overcast. So initially we are calculating for sunny. So SV is nothing but subset of sunny over here. First initially sunny we are calculating. That is the reason for this sunny subset we got 0.97. Okay. 0.97. And then we are doing the calculation, and then we got the information gain value. Okay, then we got the information gain value. Clear? Clear? Have we got the information gain? Any doubts, anyone? I'll just repeat once again how information gain is working. We'll calculate the entropy of the parent node, okay, root node, and we'll calculate the child node also. I mean the decision nodes. And after going through all the recursive splitting, we'll calculate the entropy of the child node also. Okay. And why exactly this information gain is used? It is used to determine the best feature to split the data. Okay. It's used to determine the best feature to split. See, information gain and entropy are both trying to do the same thing. They're trying to decide the best feature for the split. Okay. Yeah, entropy of Sunny value you have given, Akash. Akash, you have given entropy for Sunny. Okay. No, it should be 2 by 3 only. Because we are considering the subset values over there, not the complete values. Okay, subset values over there we are considering. Okay. S of V only. If you look at the formula, how the formula it is SV. Okay. SV by S. So similarly, for humidity, we are considering the dataset based on humidity, and then the entropy is calculated. Okay, correct. You're saying 5, right? Yeah. S is 5, correct. Should be 2 by 5 again. Correct. Fine. Yeah. Number of 5 samples for Sunny. So it will be 2 by 5, 2 by 5, 3 by 5. Okay. And 3 by 5 again. Thank you. So again, for information gain for humidity, we are splitting the dataset based on humidity, calculating the entropy again, calculating the information gain for wind, and to calculate for the wind also we are calculating this. And then what are we doing over here? So then what are we doing over here? Based on the highest information of the feature, we are going. So this one outlook is giving the highest feature, correct? Is giving the highest value around 0.86. And if you look at the other two values, that is humidity and wind, they are giving around 0.56 and 0.69. So when compared with outlook, humidity and wind information gain values are very low. So that is the reason we are considering outlook as the main value or the root node. Okay, outlook as the root node or the main value. Calculate the information gain, and based on this only, as outlook column is having high value like around 0.86 when compared with other columns or features, so we are considering outlook as the root node. Okay, clear? Yeah, it should be 2 by 5. Thank you. Clear, anyone? I mean, everyone clear, right? Any doubts? Yes, correct. I see one of your friend is saying a statement like it means that greater the information gain, lesser will be the entropy. Correct. Okay, fine. So here, remember, high information gain means low entropy. Okay. low information gain means high entropy. Okay, fine. So we need to discuss another important key factor over here, that is Gini index. Okay, Gini index. Gini index is important again. What is Gini index? Gini index will measure the impurity of the node. Okay, Gini index will measure the impurity of that particular node. Remember, Gini index will measure the impurity of the node. Okay. So here we have discussed about this entropy, information gain, and Gini index. Okay. So all these three things are different types of the splitting criteria and will help us to find the best feature. Okay. Will help us to find the best root node. Okay. So this is it for decision tree, guys. This is it for decision tree. So now comes the random forest. I hope everyone is clear with the decision tree. Now comes the random forest. So what is this random forest? What is random forest? Anyone? See, before going into random forest, you need to know about ensemble methods. Okay, ensemble learning or else ensemble methods. In ensemble methods, we are having two different types: bagging and boosting. Okay, bagging and boosting we are having, and this random forest is one of the bagging method. Okay, random forest is one of the bagging method. Exactly, the random forest algorithm does this. It will combine the multiple decision trees. Okay, it will combine multiple decision trees to improve the accuracy. Okay, combining multiple decision trees to improve accuracy. That is what the random forest will do. See, in decision tree, what's happening? A root node is being calculated, and based on that, recursively the splits are happening, and we are getting a leaf node. So in a similar way, in random forest also, multiple trees will be created. Okay, multiple trees will be created. Why? After creating those multiple trees, what exactly happens is it will combine all the decisions of those multiple trees, and we're getting a final tree output that we'll be calling it as, like, that will be basically used to determine the accuracy. Let me just show you. Tree 1, tree 2, and tree n. It's like depending upon the number of trees, how many trees we want to divide. Okay, and this tree, and this tree, like, let's consider we have divided, or else we have considered 3 trees over here. 3 trees have been built. Okay, so based on combining the 3 trees values, we'll be getting a final tree output value, that which will help us to determine the accuracy. Okay, and how we are calculating over here, depending upon the voting, we'll be considering the voting. What this tree is classifying more? This tree, the tree 1 which is built, it is tending towards more towards A class. Tree 2 is tending towards more A class, but tree 3 or B, or else tree N is tending towards output to class B. So voting, by doing the voting, we'll be calculating this, and we'll be going for which tree to consider. Okay, which value to consider. We'll be going for which value to be considered. We'll just dive into this. Fine. If you see decision trees, random forest is composed of a collection of decision trees. Decision trees are hierarchical structures where each internal node will represent a feature. Each branch will represent a decision based on that feature, and each leaf node will represent the outcome or class label. Okay. Based on that, the random forest will utilize the decision tree as its base learner. Okay. Here, this is another important concept: base learner. If you see over here, bootstrapping method. So what is this bootstrapping method again? It's the same. If you see, random forest employs a technique called bootstrapping. to create the multiple subsets of the original data set. So on the original data sets, first initially, the multiple subsets, okay? The major data set will be divided into multiple subsets. Based on that multiple subsets, multiple trees will be created. Okay, multiple trees will be created, and by considering all those multiple trees, we will be doing the voting. Okay, we will be doing the voting, and from that we will consider any major output tree. Okay, we'll just go through this. So it will employ a technique called bootstrapping to create multiple subsets of the original dataset. Bootstrapping will involve randomly sampling data points from the dataset with replacement to create the new datasets of the same size as the original also. And each decision tree in the random forest is trained on one of these bootstrapped datasets. See, first initially we'll have whole dataset. From that whole dataset will be divided into subsets. Okay, whole dataset will divide into subsets. And after dividing them into subsets, each subset will form a new tree. Okay, each subset will form a new tree, and each subset will have randomly picked values. Okay, each subset will have randomly picked values. So those each subset, let's say I have divided my whole data set into 4 subsets. So each and every subset will have a tree. So I will have 4 trees. So by doing the voting, okay, by doing the voting, we'll consider any one tree or the average, not the average exactly, the majority. If you see over here, tree 1 output is A, tree 2 output is A, tree N or else the last tree output is B. So based on this, we are considering this voting. Based on the voting, we want A. Understanding? Understanding, any doubts? The replacement, where it is, yeah, here. So what it is saying, random forest will employ a technique called bootstrapping to create a multiple subsets of original dataset. Bootstrapping involves random sampling data points from the dataset with replacement to create a new dataset of the same size as the original. Okay, fine. So instead of creating the new datasets, we'll consider the sampled data from the subsets only. Okay, whatever the subsets which have been divided or been considered, on the subsets only we'll draw the new tree instead of creating the new data points. Instead of creating the new data sets, we'll consider those subset trees only. Okay, that is what with replacement is. Okay, the remaining process is all the same. Okay, remaining process is all the same. But one thing here, we have voting and averaging over here. Where does the voting and average comes? Here, if you see voting and average will be coming. See, the output from all the subsets will consider one major output, right? And how we are considering that one major output? By depending upon the voting and the average. Okay, voting is used for classification task. Okay, and averaging is used for regression task. Remember, okay, voting is used for classification, and for regression task we'll go for average. Okay, and other things are all the same. So if you see over here, during prediction, random forest combines the predictions of all individual trees to make the final prediction. For classification task, it uses the majority. Correct. Majority is nothing but the voting again. Okay, for classification, we use the majority of the voting. And for regression, we'll go for average. We'll do the average. Okay. We'll do the average over here. So ensemble learning, if you see over here, random forest belongs to ensemble learning family of algorithms. Ensemble learning combines multiple models to improve the predictive performance compared to any individual model. Random forest leverages the wisdom of crowds by aggregating the predictions of aggregating the predictions of multiple decision trees, resulting in better generalization and robustness compared to single decision tree. So when compared to the value of output of a single decision tree, here we will be combining multiple decision trees. Depending upon the regression or classification, we either go for voting or else we either go for averaging, and we will be considering the output, final output. Okay. So that is what exactly happens in random forest. Any doubts in random forest? Anyone, any doubts in random forest? Guys, if you're having any doubts, let me know here itself, okay? If not, everything is clear, we'll just proceed with the KNN. I will explain overfitting, okay? Once we are done with this KNN, I will explain overfitting. Shall I proceed with KNN? I see only few responses. Shall I proceed? Yeah, fine. So then comes the KNN. KNN is having also another name. Anyone know that name? Anyone know the other name of KNN? There is a name for KNN actually. KNN is K nearest neighbor, okay? KNN is nothing but K nearest neighbor. There is another name also for KNN. We will be calling it as the laziest algorithm, okay? The laziest algorithm. In all the machine learning algorithms present, we'll consider KNN as the laziest algorithm. And this KNN is a supervised learning algorithm, okay? And it can be used for both classification and regression, okay? And this KNN will work mainly on the one small, or else you can consider like it will be working based on an idea or the concept, like the similar data points are likely to have similar target values. Okay, the similar data points will have similar target values. So based on that concept only the KNN will be working. Okay, similar data points will have similar target values. So based on this concept, the KNN will work. And KNN is a supervised learning algorithm. It can be used for both classification and regression. Okay, classification and regression. And KNN is called as the laziest algorithm. Now we'll see how exactly KNN works. Okay, KNN, it will work based on the distance calculation. Okay, it will work based on the distance calculations. And how the distance is calculated based on the Euclidean distance, Manhattan distance, or else Minkowski distance. Okay, there are three different distance metrics we can consider to calculate this KNN. Okay, based on that only we'll be calculating this KNN, like what data points belong to what target values. We just proceed. See, let me just complete this. Fine. So this is an X and Y. This is a chart where we are having two different values over here, red and blue. Okay, red and blue. So now what exactly happens is what I told, KNN will work based on distance metrics, right? Distance metric. So we are having many distance metric. One of the distance metric is Euclidean, okay? Euclidean metric. And if you see over here, what are the colors we are having? Red and blue over here. So now there is a new data point, which this one is a new data point, okay? This one is a new data point. So now I need to calculate to which value does this new data point belongs to, okay? To which target value this new data point belongs. See the concept, how the KNN is working. What is the concept of KNN? Based on the similar data points will belong to, or it will have the similar target values. So these are my similar data points of the target values which are belonging to red and blue. So now I have a data point. Now I need to calculate to which target value this particular new data point is belonging. So in order to calculate that, we are having distance metrics, okay? Distance metrics. So we have three different distance metrics. One is Euclidean, okay? Euclidean, we are having Manhattan, we are having. Okay, so we'll discuss about this Euclidean. Anyone know the formula of Euclidean distance? What are the different values we'll have in the Euclidean? We'll have a point A. So this is point A and point B, where we'll have two values in point A and two values in point B. And based on those two values only, we'll be calculating the formula. So what is the formula of Euclidean distance? X2 minus x1 whole square plus y2 minus y1 whole square, completely under root, okay? Completely the whole formula will be under root. Remember the formula? Remember the Euclidean distance formula? Yeah, x2 minus x1 whole square plus y2 minus y1 whole square, completely under root. Correct. Right. So based on these two formulas, so now we'll have x1 value, x2 value, okay? We'll have x1 value, x2 value. And similarly, we'll have a y1 value and y2 value, okay? So based on those 2 points, based on those completely how many points for x2 and y2 values. So based on those values, we will be calculating, and whatever the target value which is near. So this is a new data point. So Euclidean distance formula is this, and Manhattan distance formula is this. What is the Manhattan distance formula? Xi by I modulus of I1 to K. I1 to K. And I forgot to mention this. So initially we'll also define the K. Okay, we'll also define the K. How many K values to consider we'll be defining. Mostly we'll be giving it in the format of odd numbers only. Okay, we'll not be considering any even numbers. We'll consider odd numbers over here. And we're having this another distance formula, Minkowski. Okay. Fine. So you people got to know how we got this xy and x1 and y1, right? X2 and y2, correct? Okay. Fine. So how the workflow is happening now? First we will be considering the number of Ks. How many Ks to consider? Okay. How many Ks to consider? We will be considering that, and then we will be calculating the distance. Okay. And after calculating the distance, we'll select the nearest neighbor. Okay. We'll select the nearest neighbor based on this distance calculation. Okay. And then we'll tell that particular this green label is very near to this red when compared with this. So this particular new data point will comes under this particular target values. Okay. So here we'll have x1 and x2 value for this, and similarly we'll have a y1 and y2 value also. See, this one will be x1 and x2, y1 and y2. So whatever the nearest target value data point is, it will just go and tell, I mean the new data point will be assigned to that particular target value only. So that is the reason we are calling this KNN as a laziest algorithm, okay? That is the reason we are calling this as a laziest algorithm. And what are some of the advantages of KNN? It is very simple to implement, correct? It is very simple to implement, but it will work very slow for large data sets, okay? It will work very slow for large data sets because it need to calculate that particular based on the distance formula, correct? So it will be calculating very slow for the large data sets, okay? Remember, KNN can be used for both classification and also regression, okay? And why we are calling this as a lazy algorithm KNN? Because it is using the lazy approach, okay? Lazy approach, making the KNN simply to implement. See, by just looking at the topic and by the explanation of the topic, even you people are, I mean, able to understand that a new data point comes in and it will do the calculation based on the Euclidean distance, and whatever the nearest target value it will go and consider, I mean, the new data point will also consider that value as a target value, correct? New data point value will also lies under target value. So it is just whatever the nearest target value it is just going and telling that even I belong to your target value only. So it's like a lazy approach, but in a computational way, in a calculative way, it's completely, I mean, it will be taking much more time. Okay. So this is pretty much about KNN. So I told you, right, we'll consider the K value and mostly we'll be considering it as odd values, right? So let's consider K value as 5 and we are having a new data point. And 5 means how many it is considering? The nearest 5 data points it will consider. Okay, the nearest 5 values it will consider. So these 3 are very near and these 2 are very near. Okay, it is considering how many 5 values it is considering. After considering those 5 values, based on the nearest, if you see over here, see, even by looking at this plot, you can say this one is the nearest label. So this new data point will also be assigned to this nearest label. So, and if you see the majority of the values, if you see over here, this red color circles or this red color target variables are very high in number when compared with this blue. So it will tend to join this particular group only. Okay. So that is the reason even this label is joining this particular target value label. Okay. See the steps now. Choose the number of the k. Take the k nearest neighbors of the new data point according to the Euclidean distance. And then among the k neighbors, count the number of the data points in each category and assign the new data point to the category where you counted most neighbors. Most neighbors, in the red color we are having most neighbors, correct? But mostly k will be considering 5, okay? But if you are having more huge amount of data, then we'll go for 7. Fine. So choose the number k, take that k nearest neighbors of the new data point. So from the new data point, consider the nearest 5 values as we are considering k as 5. And then we will do the Euclidean distance. And after doing the Euclidean distance, among the k neighbors, we'll count the number of the data points in each category. Each category, whatever the categories we are considering, in each category will calculate the number of the data points and we'll assign the new data point where the most neighbors are present. In the plot, for red, we are having most numbers. So we are telling that new data point also lies in the red color. Then the model is red. So this is how the KNN works, okay? That is how the KNN works. Any doubts in KNN? Any doubts in KNN? Okay, fine. Step 3. Okay, fine. And you can consider CIC another query. What should be the range of k values? See, you can consider the range of k values in between 3 to 10, but mostly go for odd, okay? Mostly go for odd and don't consider k as 1 or else 3 because it may lead to overfitting, okay? It may lead to overfitting. So I see one query, if you take the odd value of k, then every time one category will have more number of neighbors than other category. Yes, that is true. That is true. That is why it's laziest algorithm. If you consider an even number, again you need to do a average or else how you will be calculating. It's better if you consider it in an odd, okay? Okay, fine. Clear, Akshay? Okay, Parikshit and Sharma. See, to avoid ties, okay? To avoid ties, we'll go for odd values, okay? To avoid ties, we'll go for odd values, remember. Let's say if I'm having a tie now, it will be very unclear which class to assign the new data point to. Correct. So it's a best practice to go for an odd value, okay? Odd k value. K, 5, 7, 9. Correct. We can choose any one of them, but choosing 5 will be much better, okay? Choosing 5 will be much better, which won't be leading to any overfitting or underfitting. Remember this, if you are choosing k as 1 or 3, it may lead to overfitting. And if you are choosing k as 7 or 9, it may lead to underfitting. Okay, so the best k could be 5, okay? So I hope it's clear for you, Akshay and Shashank. So now I'll just repeat the third step. So what was the third step here? Yeah. So choosing the number of k neighbors. So let's say k is 5. So then take the k nearest neighbors of the new data point. So consider the 5 nearest neighbors for that new data point. And how we are considering that 5 nearest neighbors based on the Euclidean distance. And among the how many k neighbors we are having? 5. Correct. 5k neighbors we are having. In that 5k neighbors, count the number of data points in each category. How many categories we are having? 2 categories, blue and red. So in each category, count the number of data points. So in red, we are having 3 categories, 3k neighbors and 2k neighbors in blue category. So now, how many k neighbors? 5k neighbors. 3k neighbors in red, 2k neighbors in blue. So based on that, we will be assigning the new data point to category where you counted the most neighbors. So in red k neighbors, and I got the most number of k neighbors. So whatever the new data point I'm having, I will assign that new data point to this most neighbors. Okay. Clear, Parikshit? Parikshit and also Sharma. Clear? Do you want me to repeat again? What about Akshay? Thank you. Fine. I hope random forest, decision tree, and also KNN is clear, right? Okay, so one major thing was left over for us, right? What was that major thing? Anyone remember? When did we do our implementation? Remember anyone? We did very long back, right? We did very long back. So now we will be implementing this linear regression, logistic regression, decision tree, random forest. Okay, we'll implement all these 4 algorithms now. Okay, I see my voice is breaking in between. Is it same for everyone? Was my voice breaking in between? Or is it fine? Okay, it was breaking a lot. Okay, voice is fine. Voice is not coming earlier. Explain Euclidean distance. Euclidean distance. Yeah, Euclidean distance will work based on the mathematical distance formula. X2 minus x1 whole square plus y2 minus y1 whole square. This complete formula will be under root. Based on the new label and the nearest K1 label. Let me just explain once again. Okay, I see many complaints now. Thank you. Let me just open my OneNote. Let me know once you are able to see the OneNote, okay? Okay, earlier it was, but everyone understood, right? This KNN? No need of explanation, right? Again. Okay, fine. Then I'll stop my screen. Okay, thank you. Okay, so we'll just have a short break. Okay, we'll just have a short break, and after the break, we'll do the implementation. Okay, we'll do the implementation. Okay. Please have a short break, please. Thank you. Okay, I hope everyone is back from break, and I also see many queries. Okay. Employee performance prediction is not showing structure and code image in the project. Amit, thank you for raising this concern. So, and remember, your mentor will be Sai Kiran, okay? Your mentor will be Sai Kiran, and we are noting down all the queries, okay? Fine. Okay, again, employee performance prediction not showing structure and code image, fine. And I see one query which is too big. So there were 4 courses, 4 were done. Okay, the following courses were done, and you're finding it difficult to complete remaining months. Okay, fine. It's totally fine. They are self-paced course, right? So try to resolve as much as possible. I mean, try to complete as much as possible. They were just the self-paced courses, right? So as per in your free time, just learn the concepts and try to complete them. Okay. Okay, fine. So question from previous session, do we need to apply all the methods of data pre-processing in a model? I mean, this query I haven't seen in the previous session. I'm sorry, Saba. Do we need to apply all the methods of data pre-processing in the model, or we can apply accordingly? See, accordingly we need to apply, but that accordingly also we need to make sure that whatever the method that we are applying, that should be reasonable method, okay? I mean, that method should be reasonable over there in that process, okay? See, in that notebook explanation, the scaling part is not required. So just for explanation purpose, I have added, but in the complete model building part, I didn't add, correct? So in a similar way, wherever it is required only, you need to add those steps. But mostly following all those steps is good. Okay, it will help you to understand the data more clearly. Okay, thank you. So let me just open that notebook. What was the notebook name, guys? Pre-process, correct. And let me just share the screen. I'm sharing the screen. I'm sharing the single screen. Okay, now, so just look at the screen. First, we need to connect, right? So let me just connect this. Just a moment. Click on connect. So new runtime will be assigned for us. Still connecting. We'll just wait, okay. Okay, it's connected. Let me just run these cells. Let me just run the cells, and let me just zoom into. It's been a very long time, right? Let me just run this. You all know what is happening in each and every cell, correct? No of explanation. Correlation, not much required. Okay. Okay, until here it's done, correct? Until here it's done. So now after splitting the data, what we need to do? We need to call the model first, okay? We need to call the model first. We need to import the model, and then we need to fit the model on the training data. So to do that, from sklearn dot model selection, not exactly model selection, we are having this what we need to import, we need to import linear regression, right? So sklearn dot metrics we are having, just forgot that library, just a moment. Not metrics exactly. Let me just write here. So what are the two? First we'll do the logistic regression. Okay. First we'll implement this logistic regression. So let's see if it is showing the library again from. Yeah, sorry, linear model. I forgot that. So sklearn dot linear model will import the logistic regression. Okay. In the same also we are having linear regression, and in ensemble methods we will have random forest and decision tree. Okay. So I'll just run this. So this is the model which I am going to build because my dependent variables are species. Okay. Understanding? Fine. LR is equals to logistic regression. Okay. I'm storing that whole model in this variable. Okay. And in that variable. Now what I need to do? I need to create the model, logistic regression model I need to create. So model is equals to LR dot. In order to create a model on my data, I need to fit the model. I need to make sure that model is learning on this training data, right? So what I need to do, I need to type lr.fit on xtrain and ytrain. Okay. So the model will fit on the training data and the model will be built and I will get a linear regression model. Okay. I got the linear regression model. Now what I need to do, I need to do the predictions, right? I need to do the predictions. And what I need to do, I need to do predictions on X test, correct? So y predictions is equals to, now whatever the LR model we are having, dot predict on X test, okay? And we'll see what are all the predictions we are getting. So for the X test values, so let's visualize this X test values also. So let me just keep X test. Okay, so I have considered only top two values from the X test. Correct. On this X test values, I need to do the prediction. Okay. So the whole X test values I'm predicting. How I'm predicting? Predicting based on the model which was built. I'm storing it in the variable called y predictions. Okay. So X test is nothing but these are the first two values. For these four values, my model is predicting it belongs to 1. What is 1 here? 1 is nothing but, if you see over here, what is 1? Versicolor. So for those four values, what is the species outcome? What is the predicted outcome? It is versicolor. Correct. So this is how we'll do the model building and predictions. Okay. Understand this, everyone. Just refer to this, everyone, and let me know if you're having any doubts. Okay. I'll just give like two minutes. Just refer to that. If anyone is having any doubts, let me know. Okay. Okay, fine. So I have imported the model in this 43rd cell. Then whatever the model, I'm saving it in the variable LR. And on this LR model, I need to make sure that the model is learned on my data, right? So I'm storing the model in this LR. So it is, I'm telling the LR model to fit on the training data. That's it. Okay. I'm telling the model to learn the training data. That's it. And after learning, I'm saving my model on which variable I'm saving my model in LR underscore model. Okay, that variable I'm saving the model. Then on that same model I'm doing the prediction. Okay. Yes, definitely you'll get the notes. Okay. Clear? Clear, guys? No doubts, right? See, I told you, right? Remember? Any doubts, anyone? Yes, we predict on X test. Okay. Fine. So logistic regression is done. So classification for logistic regression is done, and logistic regression is mainly used for classification. And what are the other different algorithms which are used for classification? Decision tree, random forest, correct? So we'll implement the decision tree and also random forest. Okay. Decision tree, random forest also will implement. And then we'll go for the evaluation metrics, or else we'll complete evaluation metrics. Okay. TR metrics for logistic regression. Okay. So in order to do that, from sklearn dot metrics import, in the sklearn dot metrics we have accuracy score, confusion matrix, and classification report. Let me just run this. Okay, fine. So now confusion matrix first. So confusion matrix we'll be doing it on Y test and the Y predictions. How many values it is predicting correctly and how many values were actually correct. So that is what the confusion matrix is, correct? Let's see the table. This is the confusion matrix table. Actually, confusion matrix table will be very clear when you consider only two labels. Okay, when you consider two labels in a target class, let's say there is S and S or no values in the target column, then confusion matrix will be very clear to understand. Okay, will be very clear to understand. And I can also calculate the accuracy score. So to calculate the accuracy score, I'm just keeping ACC equals to in the accuracy score, and accuracy score will be again based on the Y test actual and the predicted, correct? Actual values and the predicted values. Remember the true false table which I have drawn, actual values and the predicted values, true false, true positive, false negative, true negative. Remember? So accuracy I got, accuracy is 0.97. In a similar way, we can do the recall. So how to do the recall? Just need to write recall over here or else recall score. You can consider anything, okay? Just see. Let's run this. We'll get an error. So recall score is not defined. Let's define the recall score over here. Okay, recall we are having. So even recall also we are getting around 97. And why did we keep the average is weighted over here? Because we are having three classes. See, in a target column, if you are having two values, then classification matrix or else confusion matrix will be very better for understanding. But if you are having three values in the target column, then we need to mention average as weighted or else micro. It will be dependent, okay? It will be depending based on that. I can even calculate the precision. Precision I need to calculate, right? Let me just give 3 to precision, and like so precision score also I can calculate. Again, I need to import the precision score too. So let me just give it over here, precision score, and also F1, correct? Another one is F1, correct? Let me just run this, run this, run this. So even I got the precision, recall, accuracy, almost all the same. So F1 score means you all know harmonic mean of precision and recall, correct? So this is how we'll be calculating the accuracy, recall, and precision on the actual and the predicted values. Okay. Now we will build the decision tree and the random forest. Two queries. Yeah, in the line 45, yeah, our model is prepared and our model is stored in LR underscore model. Okay. LR underscore model, the model is stored. And one more query was output is just for the two rows or all rows present in the X test. See, output is for all, okay? Output is for all rows present in the X test because here just for visualization, just for you people to understand what are these four values and what is this one, I have kept as 2. Okay. But this accuracy recall in this Y test, it is considering all the values, okay? All the values it will consider. The biped also all the values it will consider. Okay. Repeating confusion matrix, it will be taking another much time, okay? But refer to the previous session and just remember confusion matrix will have a true false table where we'll have the actual values and also the predicted values table. Okay, truly predicted values and how the predicted values are, how the actual values are. That's it. Okay. See, why predict of the predicted values? Predicted values of what predicted on X test. Y test are the actual existing values. Okay, actual existing values. If this value and this value is matching, that will be true positive. Correct. So that is how the confusion matrix will help us. So now I need to import the decision tree. So what is the library for it? From sklearn.tree, we need to import decision tree classifier. So let me just run this. So after running this, what I need to do, I need to define that model, right? I need to store my model in any one of the variables. So I'm storing it in dt. Okay, I'm storing it in dt. Then after storing that model, I need to create that model, right? So dt model is equals to dt dot again fit xtrain and ytrain. So now I'm storing my model over here. Again, I need to calculate the y predictions. Y predictions of what? dt. Correct. So it will be dt model of x test, and these are all the predictions. This is how the decision tree is working as per the predictions. And to calculate the accuracy score and all those things, the same metrics, okay, the same metrics. So let me just calculate the accuracy score for this. So what will be over here? Instead of vibrate, it will be vibrate of dt. Okay. So in a similar way, you can build a random forest model also. And to import the random forest classifier, you need to call ensemble, okay? Ensemble, okay? Fine. So RF will be the random forest. Let me just call it random forest. Random forest classifier. It is a method, right? Okay, random forest. RF underscore model. RF underscore fit. And after fitting the model, what I need to do? After fitting the model, I need to do the predictions, right? Vibrate of RF. Okay. So these are all the predictions. Now I can calculate the accuracy score for this also. So instead of this y grade of dt, it will be y grade of Rf. That's it. This will be the accuracy score. But one more thing you need to change over here is Rf, because for every model it will be different variable, right? Because if you are assigning the same variable, the previous assigned value will be gone, right? dt, and this one will be for, this is for what? LR, right? Logistic regression. Okay. So this is how you build the models. Okay, this is how you build the model. See, building the model is very easy, right? But pre-processing the data was very tough. So anyone can build the model and do the predictions, but understanding the data and implementing the data is very tough. Okay. I'll just conclude the session for today. You people can continue with the regression. See, I did the classification, right? Do the regression. Okay. You know how to do the regression, right? Consider any one of the column. Consider any one of the column as a target variable. And how the target variable should be for regression, it should be numerical, right? So I want everyone to do the regression problem and apply the linear regression, decision tree regressor, random forest regressor. Okay, do that. If anyone is having any doubts in this whole notebook, let me know. Doubts in the whole notebook, let me know. If everything is clear, please just drop a reaction or just let me know in the Q&A. And remember guys, please do the regression type. Okay. Yeah, I will share the notebook. Don't worry. I had just created a small poll. Let me know over there. Okay. And in the next session, we will pickle the model and we'll create a Flask. Okay. We'll pickle the model and we'll create a small Flask file for this and we'll do the predictions. Okay. And in the meantime, I'm naming this notebook as model building. And right now I'll just upload that file. Okay. Just give me a minute. I'll just upload that file. And give me a confirmation on that. Okay. Once check and please let me know. I have just uploaded the notebook. Updated from your end. Were you able to see the notebook? Let me know guys if you're able to see the notebook. I see one no, like 1% didn't understand the working and implementation. Please let me know what is your query, okay? If you guys have your queries, there is no response to me related to project assigned, so please solve this. Yeah, project assigned. What exactly project assigned, Ali Ansari? Could you please brief that query? And actually, you're saying we have small question like to update session requirements. Yeah, I'll inform that actually. I'll inform them. Conclusion of the predicted result. Sahu, I'm not getting your query. Could you please elaborate it. The recording for the last session happened on July 9th. Still not yet uploaded. Okay, fine, got it. I inform them, okay? Please share the drive link. Where is the notebook? Please share the drive link. Play performance. Okay, Amit, noted, okay? Noted. Thank you. We have a long break since we could have revised the lecture, but the session record was not present. Okay, got it, Akshay. Notebook is invisible. Please share the drive link. Amit, I got your query, okay? Akshay, Amit, Parikshit, Priya, I got your queries, okay? Just a moment. Any other queries, anyone? Yeah, I have uploaded from my end. The internet, I don't know. A minute. Let me just delete that file processed. Processed file. Or else let me do one thing. Were you able to see? Has been updated from my end. Were you able to see? The file name is model building, and I'll just share that drive link. People are requesting the drive link once again. Let me just share that. Visible, solve the problem first. Okay, Amit. Akash, please check once again. Thank you. And I'm posting the drive link over here once again. So drive link for notebooks. Please refer to that. So Arun, Devesh, and Savita, are you having any other queries? I see you people are raising your hand. Okay, so if no one is having any other queries, thank you. You may leave the session, and I see 2 no's. May I know the reason for 2 no's? If it is related to the session, please let me know. Okay. Meaning of the predicted result we got from the model that we just created. See, meaning. See, what is accuracy? How accurately our model is predicting, right? What is precision and recall, sensitivity and specificity, all those characteristics, right? In the last session, we have discussed those evaluation metrics, correct? Based on those evaluation metrics only, we are considering this accuracy, precision, recall. Okay. How accurately our model is predicting. Okay. How precisely our model is predicting. Okay. Fine. Okay. Handouts. Yeah. Okay. Handouts have not yet been uploaded. Okay. Handouts. Fine. I'll look through that, okay? I'll just make sure I look through that, okay? Fine. Got the values like 0, 1, 2 in the end result. See, those are the predictions, okay? Sagu, those are the predictions, okay? Those are the predictions. Actual values we are having in the y-test, and we are doing the predictions on the model. Based on those actual and the predicted values, we will get the accuracy score, recall score, precision, all those scores we will be getting. Okay. Clear? Still having any doubt? Still having any doubt? Okay. Fine. So just go through the notebook, everyone go through the notebook, you'll understand everything clearly. And also along with this, I'll provide another 2 notebooks. Okay, I'll provide another 2 notebooks. It will be very much helpful for you to understand the data. I have worked on them long back, so you'll be able to understand them. Okay. Fine. So I need to address that images issue on employee performance project and also the handouts. two main issues, right? And also recordings. Got it. Thank you. So thank you guys. Thanks for joining the session, and I hope no one is having any other queries. This is it for today. You may leave the session, guys, if you're not having any doubts. Thank you. Thank you, Shivam. Thank you, Shishak. Thank you. Let me see prototype of the project. Okay, yeah. Tomorrow I will try to show, okay? I mean the project which I was saying, or is the project which was assigned to you, you are saying. Thank you, Shivam. Thank you, Savita. Thank you, Sahu. Assigned to me, like this, regarding your project thing, whatever the project which has been assigned to you, you can see through the portal, okay? You can see through the portal, you can understand the project. And if you're still having an issue in understanding the project, all those things will be resolved by the mentor, okay? Mentor. And if you're still not understanding, then I will be stepping in and I will be resolving it, okay? Yeah, got it, Sahu. Images, got it. Yeah, thank you, Kushi. Okay, guys, one last session we're having on Wednesday. So I want everyone to be over there because that session is very important. Because up to model building, by watching any random videos or else by looking through any blogs, we can build. But taking that model into deployment process is very important, okay? Where you will be getting to learn about Flask also. Okay. Thank you. This is it, guys. Thank you. Okay.